Hi. First things first, I'm Matt. So I am a software engineer, and I've actually given this talk actually quite a few times to at my job, and then for other people in general. I figured, hey, like this is pretty popular. People like to understand this stuff, and so I figured, like, why not make a video out of it? Um, as you hopefully know from the title of the video. This is going to be about sort of Unix programming or Unix network programming, and sort of how to do sort of the basics of network programming on a Unix or actually specifically Linux system, and then also hopefully we will be able to build a full server and kind of show you how that works, and then hopefully turn it into a web server, which is going to be basically the most ubiquitous thing on the internet today. Web servers are everywhere. Like if you I mean, all those URLs, they are served by web servers, and that's, even your phone gets basically traffic from web servers now. Alright, so I have, like right here, my quick, very fresh dev environment. My dev environment is just a terminal, so I don't use IDEs. I kind of evolved out of that. You'll probably see why. It's not convenient for me to work with IDs a lot, especially when you're doing network programming, and you'll see. But here I just have a new folder. This is a Cygwin terminal on my Windows system, actually. This is what I'm recording on, and I'm using my Windows system because if we're going to write a web server, I'm going to write it locally. We're going to test it locally. So this doesn't require you to have access to cloud or anything really advanced. This is just, you could do this on your laptop. If you got a MacBook, even better, because you pretty much got a terminal right there. You should have pretty much all the tools I have. Windows doesn't come with this by default. This is in a Cygwin install on top of Windows, but that's pretty easy to do. It's got a nice GUI installer. I'm not going to talk about that. Go check it out if you want to look at it. Alright, so what are we doing? So we're going to build a socket server, and we're going to do that from scratch. If you don't know what a socket server is, that's what we're going to talk about. So from scratch, what does that mean? We're basically just going to be using Unix network primitives, and we're going to be doing it in Python, so we're going to have some convenient stuff. This isn't going to be C level. That would be a bit much. But we're going to basically explore the Unix syscall layer and up. So we're not going to be using the Python standard library, HTTP libraries, or TCP libraries. We're going to do that ourselves. So why are we going to do that? So this is really good to understand sort of the basic stuff in network programming. This is going to be obviously Unix, Linux focused. The sockets interface that we're going to be using actually works on Windows too. So this could work on Windows. The interface is slightly different, but you probably won't hit those just writing a basic server. And basically what underpins all of the frameworks that you're probably used to seeing if you've actually started writing a web app, or if you've used Node.js, or if you've used any of the Python frameworks like Django, Flask. If you're not familiar with these, I'm sure in your language of choice that you probably are aware of some high-level server framework or web service framework that you are using that you're familiar with. We're not going to do any of that. This is going to be more focused on the low level, and it kind of will give you some insight into why those frameworks are useful and what they are doing, kind of the problems that they are handling for you, which is good to know because frameworks are great, but until they break, and then you have to go and look and debug them, which is not fun. That's tends to be like a lot of what that's a lot of where I got my knowledge in my job. So fixing things that break. And then third, basically, hopefully we can remove some of the mystery of those service frameworks, and just how it's not. I kind of want to show it's not actually that hard to build a web server or a TCP server or just a socket server in general. It's kind of hard to build them well. To make it performant, to make it reliable, that tends to be difficult. but just to build a basic one and get the basic networking working, it's actually not that bad. Alright, so let's start. So as you can tell, I have no files. Do a list again. It's just that summary file I got. By the way, I do use Vim. You don't have to use Vim. You can use Emacs. I really don't care. You know, I am going to be doing this on terminal. If you use Nano, I might make fun of you, but you know, whatever. Alright, so let's basically with Python, we're just going to build a file. We'll call it server because we're really original. So, first thing we're going to do is we're going to import the socket library. So this is the Python socket module. It is effectively more or less a straight port of the Unix sockets. So what do I mean by Unix socket? So Unix socket library, basically, you're going to see, those are the syscalls. So the syscalls are the things that are talking basically directly to your kernel. So like the Linux kernel in this case. Or you're talking to one of the, if you're on Windows, you're talking to some Windows subsystem. Microsoft Windows is a microkernel, so it's got a bunch of parts. But you're basically going to be talking, opening up. You're going to be asking the operating system, which is, you know, whatever your thing is. I guess I forgot Mac. It's a mock kernel, whatever. You're going to be asking them to sort of open a socket, which is what we call it, and that effectively lets you start listening for incoming connections on the internet. So we're building a server. This is going to be a client-server model. So we're going to basically say to the operating system, like, hey, we want to start listening for people who are going to talk to us, right? We're going to start accepting phone calls, right? And then once the phone call arrives, then we will be writing our own code to deal with that, and then we will be sending data back and forth once we basically get somebody to talk to us. So we also have to write a client too. It's actually not that bad. We're going to focus on the server first, so let's do that. So let's build our main. Oh, what happened here? Okay. Def main. So we need a main method. Let's build our socket. So I'm just going to call it S because I like to use short names. So the socket call is just socket. This is effectively mapping to that Unix stuff. We need to, the first thing you give it is the address type, and I typed that wrong. So this is a constant from the socket library. It's address family internet. So that's internet. Basically, we're talking IPv4. Internet 6 works too. I'm just going to focus on 4 because reasons. It's simpler. And we have to tell it the protocol. So we're going to do sock stream. So sock stream is the TCP one. Contrast that with like something like dgram, which is a datagram. That's a UDP protocol. Not going to get too far into that. There's also a Unix one. We're going to do streaming sockets because this is basically what everything does. So HTTP, you know, the thing that runs the web, that's all TCP. So we're going to do that. We're going to trying to build towards sort of our own web server, right? So we got a socket object. That's neat. Doesn't really do anything yet. So the next thing we got to do is we got to use bind. So we have to bind it to an address. So because I want to make this easy, I'm going to bind it to localhost, which is a special address that basically it's an IPv4 address that is referenced to yourself. So it's like you can have network connections that can only route to yourself. In this case, we're going to be only listening to people talking from ourselves to ourselves. That seems kind of silly when you're writing network stuff, but it's actually pretty useful, especially for development. And it also can be useful if you have advanced networking cases, which I'm not going to talk about, but if you know what I'm talking, you'll know what I mean by that. Alright, we're going to bind, so that's the address. We're going to bind to our local address, and then we're going to bind to port 5000. I just like to use that one because that was actually the, I think this is like the Flask API default port. I don't know, I just keep using this one because it always seems to be free. So port is, actually I should probably talk about that. So port is basically on this address, per address you only have about 600, what is it, 65,565 5 ports, although realistically it's much less than that, because the operating system and other utilities or other applications on the system are going to be using some. And that's basically every outgoing and incoming network connection has to have a port and an IP address combination. If that combination is the same, it's the same connection. You can't have two applications that are trying to connect outwards on the same port. That it just doesn't work. It's not going to be good. I mean, you could, but you're crossing the streams, to use a Ghostbusters reference. It's bad. You don't want to do it. All right, so we're going to bind. We're going to be bind to this address. Still hasn't done anything. We're just saying, okay, that's where we want to, that's where we want to. That's the address we want to listen on, and the port we want to listen on. We actually haven't told it that we want to listen, so we need to do that next. The listen call takes one parameter. It's actually the backlog of connections. As far as I know, in Python, this doesn't really have much of an effect. I just choose to use 128 because that's, by convention, typically what people use. I believe the listen call in C actually has more options, and those have further reaching effects. And if you're interested in that, you could read the man page for the system that you're running on. It's different per Linux, and it's different per Unix, so not different per Linux, different per Unix. Alright, so now actually at this point we actually have a listening socket. So the operating system now, after this runs and this listen call returns, we will actually have a socket that is open, and it will show up if you list the sockets open, it'll actually show up, and it'll show up as listening, and you will be accepting traffic. However, we're not doing anything with it yet. We just open a socket. We've said we are accepting calls, but we're not actually going to be answering the phone when it rings. So we need to take care of that, and you do that with an accept call, right? So accept is pretty much where your actual kind of program, so to speak, begins, your application. So once, this accept call, when you call this, your program will effectively block. And what does it mean? So by blocking is effectively, this call does not return. The program will effectively pause here until a connection comes in. And then once the connection comes in, the Linux kernel or Mach kernel or whatever operating system will basically hand you up that connection and then wake your program back up for you, and then it will return. And this returns actually the client socket and also the client address. I'm calling it a client in this case, but it's really your peer, so it's like whoever is connecting to you. But because we're using a client-server model, I'm going to refer to it as a client. So we have our socket, which is basically, this is the connection. This is different from the socket that we're listening on. This is a new socket that gets created for us by the operating system. This is what we use. This is a channel that you can use to talk to that individual person on the phone. So there's still actually another socket that's still doing the listening, and this is actually an interesting problem that you kind of have to solve when you're building servers too. But there's still the listening socket that you can still be accepting stuff off, but you also have this new client socket that you can use to talk to the thing. So you can kind of answer multiple phone calls at the same time. We're not going to deal with that yet because we just want to make this simple case work. So we're going to do that. I'm also going to put this in a loop. This is important because, actually I'll get rid of this and then we'll actually run it and you'll see why it's important. Alright, so we got a socket accept. We got a client socket, somebody has connected to us. We have the socket we can use to talk back to them. We also actually have the address information that they're connecting to us from. If we want to, you can print that out. Kind of interesting to look at that. But we need to do something interesting with that client socket, right? Because, they're just going to be sitting there. We haven't said hello yet. We've picked up the phone, but we haven't said hello. So we need to say, we need to do something. We need to say hello, send some message stuff. So client sock. So in the Python API, you can just use the object-oriented stuff. Obviously, if you're doing this with C calls, you don't have that. You got to pass the socket in as the first argument, but that's whatever. It's still pretty much the same. I'm actually going to cheat a little bit and use send all. and we're going to send them all, or we're going to send the entire message of hello world, because we're really original. So send all, there's actually a send function, and then you have to check the amount of bytes sent back from that. So you can do like sent, and then sometimes it's possible that all those bytes didn't get sent, and then you have to like do the math to calculate, okay, well I didn't get all of the stuff sent, so I have to call send again with the bytes that weren't sent. However, in Python they have a nice convenience function for you to do that for you, which is nice. It's just send all. Easy peasy. So I guess, not quite the base Unix primitives, but hey, close enough. Alright, so that's basically kind of it, except that we probably also want to do this, where we're going to close the socket after we send hello world. We're going to hang up. So we're just going to say hello, and then we're going to hang up. It's going to be confusing if anybody actually calls us, right? But hey, that's a good example, right? In Python, you don't actually really have to close it. Your close will actually, in this case, once our program ends, the close will happen. Python has garbage collection stuff that'll take care of that for us, so we don't really have to worry about it, but you should not rely on that. You should close it when you know you need to close it, especially for a server, because your server is going to usually be running for a long time, and if you start leaking those sockets, you're going to have a bad time. Server's not going to work very well after a while. So we got to make sure to close it. Alright, and that's basically it. This is actually a server that would literally work. And so to show you that, I got to finish my main method here. So we actually have to call our main method. I'm going to do that quick. So there we go. So this is just basically saying if this, if this module is run directly, just run the main method. You don't have to do this. You can put this at the top level. It's a good habit to get into, is making a main method. If you're writing Python, you should definitely do that. Yeah, it saves you a lot of pain later when you're making your application bigger. All right, so let's run this, right? Right, so it just sits and does nothing, right? Remember, it's going to block at that accept call. So we got to do something else. So I'm actually going to bring up a new terminal, and you're going to see my keychain start up, but we don't need that. So let's go back over to projects, sockets 2, and that's pretty small. Make that bigger for you. So we got our other terminal here. Make it bigger. Move it over here. All right, so let's write a quick client, because we need a client to talk to it. Why do I have? Oh, that's my old one. I could use that one. It's very similar. I'm not going to use that one. We're going to write our own. I need to go back up. That was written several years ago. Alright, sockets 2, client. Alright, import socket again, because you actually, as a client, it's the same thing. You're building a network connection, so you still got to use the same socket library. So there is an easier way to do this, and actually I think I'll show you that. There's actually a you should use it this way, actually, if you're doing a client connection, because Python actually has a really nice record keeping, or convenience / record keeping function to take care of some of this for you. And it's very similar to how you would actually build the socket as well, and then do the raw connect. This one just kind of does it for you. And also, I'm going to show you this too, but I do have the Python documents up, and so this is something else that is good to learn to do. A lot of people use their IDE to just do like the autocomplete and look at all the object methods and stuff like that. I mean, you can do that, you can get away with it for a while, but you really do need to understand at some point the methods and read the documentation of the modules that you're using, because if you're just kind of looking for, if you're just kind of looking at the object names, I mean, you might be able to guess what it is, but I can assure you your code's always going to be as far from as optimal as it could be if you just read the docs and start understanding how the module is intended to be used, right? Oh, they got a cheating method here too now. We're just going to use create connection, you can also create your own socket and then call socket connect. I'm gonna cheat, so I'm not gonna do that. Although I could show you to do that. Yeah, no, we're just gonna do it this way for now. Create connection. So that takes an address, which I probably is going to be the address we connect to, right? So it's telling us here, so this is a good example. So reading through this, connect to a TCP service listing on the internet address, a 2-tuple. Alright, so it's going to be the same kind of format that we did in the server, where it's going to be a host that's going to be a string, and then a port that's probably going to be a numeric, right? And that's going to be a tuple. So now we know that that first argument, that's got to be a tuple. We have the option to give it a timeout. Don't care about that right now. And you can also optionally give it a source address. We don't really care about that because we only have one IP address we're going to be connecting from. So let's connect to 127.0.0.1, port 5000. Boom. So there we go. That's actually all we need, and we got to actually remember that. So I'm going to call it con, and then we can do con dot read. Actually, sorry, it's receive. Let me check that. I believe it's receive. Yep, receive. And then we got to give it a buffer size. So we'll give it receive, and we'll do 4096 because that's a decent buffer size. And then we got to put the data that we get out of there somewhere. So let's call it data because we're really original. And then we'll print it. We'll just print the data. And I'm actually going to do this so that we can tell what data is what. Right. So there's our function. If name equals main. Oops. Keep that nice. Alright, so there's our client. All it's going to do is connect, get some data, print it, and we should probably close it. So I broke my own rule. Con.close. So there we go. And in fact, we'll just move this around a little bit. There we go. Great. So let's run that now. And we got to get our server back up so we can see it. We'll do Python client. Boom. Right? So there we go. Boom. Like, didn't take any time at all. So we received our hello world. And you'll notice over here, it printed the client address. So you'll see this is one of those high-level ports. This is typical of operating systems. They'll use the upper half of the range as its sort of outgoing ephemeral range. So our client basically, when we did a connect, it created a socket. The operating system assigned us an outgoing random port, and then we obviously connected to our 5000 port. But this is what our server sees the client as, right? So after that, it got the address, it sent the stuff off, we got the data over here, we closed the connection, and then we printed the data, right? And then it terminated. So that's, you remember, like we were talking about, I removed that while loop. So after it was done, so it was sitting at accept, we connected, printed the address, we sent it to hello world, and then we closed it. And then our program's done. We just terminated. So obviously this wasn't a very useful server. It can only handle one connection and then it's done, right? That's not how servers work, right? We want it to keep running and handle multiple connections. So that's why we got to put it in a loop. So we'll do that. And that's why now this close becomes important, because you can't leave it open, right? You're going to handle the request. In this case, we're calling it a request, right? We get the new incoming connection, we'll print it, send some data, close it, because that's all we do. We're just a server that you open up a connection to, we send you a hello world string, and then we close it. It's very not useful. I mean, maybe. Not great. Alright, so we did that. Let's try that again now that we've got our while true. Right? Python server. Run it again. So see, same thing. We got our data over here, client terminated, and then we got the client data, sent it, and you'll see it's still running. I could control C it and interrupt it, run it again. Let's run it a couple times, right? Keep running, up arrow, boom, 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 done. So there you go. We have our first server. It's kind of interesting. You can actually see how it's incrementing the ports there. So that's a server, right? That's it. It's not fancy. That is TCP for you. So easy peasy. Obviously, it's not super useful. You can. I should probably show you guys that what you would really want to do is build sort of a what is termed a multiplexing server. So right now our server really is kind of a one-trick pony. It really only does one thing and then closes the connection. So what if you said we wanted to open the thing, get some data from the client, and basically take a different path based on that data from the client. So if the client says, like, you know, maybe we have a client send like hello, and then it wants to, and then we will say hello world back and then close it, or the client says like, you know, ping, and then we just send it, you know, a pong and then back. So basically the string would be differed based upon the client input, right? And that's kind of more what web servers do, which is why we're going to go do that. By the way, I'm just changing this to print this nicer. You know what else is really nice to do is to, right after you start listening, print listening. And actually I'm going to change this a little bit, so now we're actually getting a little bit more complicated, but you know, man, just do this. Alright, and listening on %r %adder. Right. So I just turned that into a variable. We're going to hand that to the bind so that I can print it out. So then we know that our server actually started properly. It's kind of a nice thing to do when you're writing socket servers, is to actually, you know, indicate that the server is actually started listening, because otherwise it kind of just hangs out there without any input. You don't really know what if it succeeded or not. Especially in C, if you don't check your return codes. Oops, I got a bug. Oh, it's because it doesn't like my tuple. Why, you don't like my tuple. There we go. Alright, great. There we go. I bet you its client's going to do that too if I don't do that correctly. Alright, there we go. Kill that. Boom. Alright, so make sure it still works. It's always good to test. By the client. Boom. There we go. Yep. Nice and happy. Alright, great. Alright, so let's actually change this now. Instead of just sending hello world, let's do this. So we'll do like if data equals hello, then we will do that. By the way, it's going to be bytes. Either way, we're going to be closing at the end. So we're still going to just we're still going to read some data from the client, take a different direction based on that, and then we're still going to close the connection. And you'll, when we get to a web server, that'll kind of make sense why we do that. So we got to read data from the client. So how do we do that? That's actually pretty easy. Same thing. It's the same interface as the client actually. So we got to do a receive. Let's receive 496 bytes up to get some data. That's our data. So then basically, if data is equal to hello, we will do that. Otherwise, so else if data equals. Let's just do that ping pong thing. I know it's a little bit silly, but it's different. Actually, you know what we could do? I like this idea better. So we'll do get the data, and then we'll do while. Oops, no, sorry. We'll do send all. Instead of hello world, we'll say hello %s. And then we're going to inject the data in there. So let's just do, so we'll assume that they're going to send us like their name, and then we're going to basically send hello back to their name. So it's going to be kind of like an echo server, sort of. Right? So we're not acting on that data really, we're not doing an if statement, but we are taking into account that data. I kind of want to do that to show that we actually do stuff. So we got to modify our client. Oops, got to modify our client to actually send data. So let's see. So instead of just receiving data, so here we're going to open up the connection, and now what we want to do is we want to send some data before we receive data, right? So we want to do con send all, same thing that we do over here in the server, just that now we're sending before we receive. So let's just say hello, Bill. let's just say our name is Bill. And then we're going to print out the data we got back. That's actually all we need to do. Cool. And the reason why that's actually all we need to do is because once send all is done, the con receive is basically going to block until it gets data. So it actually, once we ship it off, this basically, it comes down here and tries to do a receive. The receive actually won't receive anything because we're not sending anything. So again, this is a blocking call. So this will not return unless there's actually data to be read. Well, kind of. Since this is Python, there's two cases that will return. There's actually data to be read, or if the connection has been closed. And if the connection's been closed, this data will actually be nothing. It'll be empty. That's a Python thing. C does not work like that. You just will get an error, which, you know, Python makes it a little bit easier to do that in that case, but, you know, it's just how their API has been written. Slightly cheaty, I guess, but, you know, it's still useful. Alright, start our server, and then let's run our client again. And it exploded. Yeah, so we got a connection reset by here. So that's actually... right, it actually, instead of closing it, this actually crashed. So that's actually what happens when the client crashes. So Linux basically took care of closing the socket for us because our server crashed. And when Linux closed the socket, this guy was trying to still receive connections on it. But Linux, because it closed the socket, it sent a reset packet. We got that reset error in our client. So this is just a typo because I typed client instead of client socket. You guys probably saw that for forever, and then I wasn't paying attention. Alright, cool. Let's do that. Run this again. And there we go. Hello, Bill. We could actually make this even more interesting and just take this as input from, so let's do import sys, import sys, and we could do send all, let's get our R, or data, or let's call it a message, and we'll do sys argv1, so we'll get the first argument, and we'll use that as our name, and we got a message encode because we need to change it to bytes. We'll assume that it's UTF-8 because it's a safe assumption. Probably going to be ASCII. That works. Yeah. Get our argument from command line, encode it to bytes, send it off. That should work. So now if I do client Bob, it says hello Bob. Do socket, sockets, socket 2. There you go. Pretty simple. So we actually kind of have a working server. So now let's change it to an HTTP, shall we? I think we can do that now. So, what does it take to do that? Well, for HTTP, I'm going to actually not use a client. I'm going to actually use an HTTP client so we can actually show that it interoperates. And so when we do HTTP, it's actually going to be fairly similar, which is why we kind of built this the way it is. We're going to get an incoming connection. The client is going to send us a request. So HTTP is a request response protocol. The way it works is effectively it opens a TCP con. The client opens a TCP connection to the server. Once it establishes the connection, the client will send a request, and the request is basically text data, exactly kind of like what we're dealing with. It's human readable. It's not byte packed, or it's not binary. It is a human readable request. It is text. It's a text-based protocol. So we basically have to take that request, read it in, process it, and then we write back a response. So once the client sends the request, it ships it off completely, and then it just sits there with the connection open and waits for data, which is pretty similar to what we actually just built, right? If we look at our client again, all we're really doing is opening the connection, sending off our request, within air quotes, and then we're effectively just waiting for the response. So that's kind of why I built this server the way I did, right? Alright, so now that we did that, let's basically change this to, let's change our server to do HTTP. So we won't be using the request. I'm going to keep this window open because I'm going to show you what client we're going to use. We're going to use curl, which is the command line thing, and then we're also going to use Chrome, which is why I have the window open behind. But let's go do this. So the first thing I'm going to do is actually what I want to do is we're going to get rid of our send, and we're going to explore the HTTP protocol a little bit. So what we're going to do is we're going to leave all of this in place. So we're still going to handle an incoming connection. We're going to print it out the address, and we're just going to receive some data, and then we're going to print the data. We're going to print the data that we get from an HTTP client. And I want to do that because I kind of want to show you that request. We're not going to respond. We're just going to close. We're going to kind of be rude for a while until we kind of see that request and how we're going to do it, or how we're going to deal with it. And then we're going to actually implement how we're going to deal with it. So I'm going to start my server, and then I'm going to make a request. So I'm going to use curl. If you're not familiar with curl, it's just a little... Oh, that's not going to work because that's broken. So we're going to have to use Chrome, I guess. So get rid of that guy. Alright, so if we're using Chrome, I want to connect to myself. So this is why I have this. So I'm going to connect to localhost. I'm going to connect on 5000. We're going to do HTTP, not HTTPS, so it's kind of important. And we're going to see, oh, the page isn't working. Yeah, we just hung up on it. But here's our data. So this is what an HTTP, Chrome keeps retrying. I hate this. Let's just end that. So here's the request. This is what a request looks like. There's a lot to unpack here. But the most important thing is the first line. So it's actually line-based. It's kind of interesting. But the first line is what's called the request line. It's got 3 parts to it. This is it's got the first thing is a get, or it's the method. So most of the time your web browser is going to be doing gets. You're not going to be worrying about too much of the other stuff. It's a get's basically the client wants to retrieve some resource at the path, which is the next component. The path component, this one's a slash, right? Because I didn't put a path in. If I put a path like, my cool web page.html, that's the path actually. Just slash my cool web page.html. And I can show you that. Let's do that quick. Make that request. It's going to break, obviously, and then we're going to kill that quick so it doesn't keep repeating. So you see that right here. That's the path. So obviously this is like if it was a web server, this is kind of what you would see. Paths can be anything. This can be a string. The only reason that it's usually a the convention of HTTP says that this has to be sort of a limited character set, and we kind of typically people have started to use it more as like a file structure directory type of path thing. But there's nothing saying that you actually have to do that. As long as the characters in here are within the correct character set, you can pretty much put dang near anything you want there. That which is interesting because by convention a lot of web frameworks will follow usually a path-based thing or something like that, but there's actually nothing that says that you can't really put just whatever you want in there. You could just put random strings and then have those route to different things. Actually, that's kind of what webhooks do, by the way. But it's just a string. The third part is the protocol number, or well, protocol info. It's got the protocol and then the protocol version. You're like for 90, I don't know, probably like 98% of your requests, this is just going to be 1.1. There may be a 1.0. I've kind of seen some old clients speak 1.0. It's not very common. Those are usually like development clients or something that's just kind of a low, like a not very well implemented, very simple client. There's also HTTP 0.9, but I have never seen a 0.9. So yeah, for the most part, there's going to be 1-1 or 1-0. There's very slight differences in how those work. For the most part, everything kind of speaks 1-1 for the even if they do say 1-0. That might be a bad assumption to make, but those are pretty old specs. And then there's actually, this is a carriage return new line. This is the escaped form, but basically it's a new line. And then after that initial request line, the next line is actually the start of the headers. So you'll start to see here that these are key value pairs. That means that this is the name of the header, and then this is the value of the header. So these all kind of have different meanings to the protocol. Some of them protocol, some of them are application. You'll notice in here, so host is a protocol level 1, so that's actually an HTTP thing. Not going to talk about that too much, just know that. Connection is another protocol one. This one's kind of interesting. It has to do with the connection. So the client here is saying, I would like to keep this connection alive so I can make another request after this one. So after this request is processed by the server, and then the server sends the response back, the client's saying, hey, I will keep this connection alive in case I need to make another request. So don't close it. This is a client request / suggestion. The server can very well close it, and the client just has to deal with that. But basically, it's a way for the client to indicate that I am capable of processing multiple requests on the same connection. The server may just completely ignore that and just say, like, nah, I'm going to close it. Tough luck. In fact, we're going to do that because I want to keep it simple, right? Right, and then the next line. So we have this other. This is definitely a client one. This is like a Chrome header. This is kind of interesting here. Yeah, I don't even know what that means. It has quite a few of these. It's supposed to be like security headers that Chrome's sending. But yeah, these are all kind of application specific. So these are things that, like, if you're using an HTTP framework, you'll probably be able to grab these headers because it's very common for your application to be able to read these and be able to take different branches in your application, different paths in your application based on these headers, right? So for example, where is the accept header? Yeah, there's an accept header right here. So here the accept header is, the client's saying it accepts text HTML, application XHTML, XML, blah, 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 blah. So you could read this and see what the client wants to accept, right? Like maybe it wants to accept text or plain text or something like that. And then your application could actually change its behavior. It could actually send either, if it wants HTML, you could send HTML. If it wants plain text, you could just send plain text, although HTML is plain text actually. So, whatever. It can be anything. It also says it accepts XML. So if you wanted to return just like some XML data, that would be fine. It's kind of up to you. These are all things that you can put in the headers as a client. And then also in the response has its own headers. So let's write some code to parse this actually, and then deal with it. So we'll ultimately we want to send a web page back to Chrome so we can render it, right? That's the whole entire point. All right, so let's do that. We printed our data. I'm going to comment that out for now because we're not going to need to print it. So we're going to start processing. So let's get that first line. So data.split. We're going to split on lines because we like to split on lines. And I'm actually just going to split the first line off because that's relatively easy. Do I really want to do that though? Yeah, I want to do that. So we'll split the first one off. So this is just saying I want to split on carriage return new line, and I want only one split. So this is basically going to process the first. It's just going to split off the first line. So then I'm going to call it request line, and the rest is just going to be, I'm going to call it the rest, and we'll deal with that in a bit. And I need to make this a byte string. So we got a request line. Request line, we can just further parse that down, right? That's going to be, let's split on space because that's always space delimited. That's what the spec says, so that's what we will do. and that's going to return three things. It's going to return our method. Remember, it was a get. It's going to return a path, which was the path portion, and then it's going to return our protocol, and we'll just call it that. So this is going to split into three things, and then we're just going to capture all that into our three variables, and then we're actually going to print that because I like to print that. So say method equals %s, and then path %s, protocol %s, inject all of that stuff, method, path. And I know there's a more efficient way of doing this, but I'm trying to keep it simple for people. So we're just going to print that out, and then I'll just print out what we got. Now we got to process the headers, so that's the rest of it. So let's do rest.split, and we'll split on the headers are also delimited by lines, so we will split on that. I don't want to limit it, so what I want to do then is basically so these are going to be the lines. So each one of these lines is going to be a key value pair. For each one's going to be a header. So let's say each one is a header, and then what we'll do is we will loop through those. So for this is going to be headers. This is actually a list. I'm sorry. So for header and headers, let's actually so I build a new variable. I'm going to actually build it as a dictionary, which is a Python thing. It's a map, if you're familiar with that. Map/dictionary. I'm going to call this, I'm going to change this header strings. And then this will be named nicer. Okay, cool. So for header and header strings, let's basically header.split, and we're going to split on, colon, and that's going to give us basically the key, and then it's also going to give us the value. Actually, you know what I'm going to do? I'm going to make sure that we limit it to 1. I don't believe it's valid to have a colon in the actual value of the headers, but you never know. You've got to kind of validate your inputs and code defensively. And then we're just going to add that to the headers as key equals value. I should probably turn this into a string. That means nothing to you, but it does to me. So, before we do that, let's do this. Decode it as UTF-8. I think technically when I looked this up last, it was supposed to be like US ASCII, but US ASCII is a subset of UTF-8, so it should be fine. And at that point, we're splitting strings. We're not byte strings. Not going to go into why that's important right now, but it's important. So that should give us a bunch of key value pairs. Let's print that out as headers. And then we'll print it headers. And then let's just send back a hello. It's going to blow up, but it'd be interesting to see what Chrome does. Alright, let's do that. Need more than one value to unpack. Why? That was right here. Oops. Yeah, it was in splitting a header. That's weird. Why would it split that? I mean, we parsed our protocol line fine, so we see that there. That's interesting. Oh, I know why. Yeah. We forgot to check if header is actually even an empty string or not. So let's do that. So we can use that in Python shorthand for checking if a string is empty or null. It's just if that thing. So this way we're defending ourselves if there's nothing to. So the last line of the request is always like an empty string. It's just a blank line. So that's probably what we're hitting, is like we're actually getting to the end of our headers. And then that last line, we're trying to split it, and we don't want to. We just want to skip it. So that's pretty sure that's where we're blowing up. Try that again. There we go. So you can see we got our request thing. And here's our headers. It's a giant freaking dictionary. But it's a little bit easier to read, so you can kind of see here now you have the connection, and then you keep it alive, and things like that. So, kind of interesting. Let's see, server, go back to our server. So we got that. Get requests specifically don't have a body, but now we would effectively start reading the body. This isn't quite the correct way to do that. So like the problem is that we're actually pretending that the headers are the only thing left in the request. Usually what you would do is you would actually do, you kind of have to look before you leap, rather than just trying to split the entire string on new line. You would actually kind of want to grab one line at a time. This is because this is a GET request, there really is no body. I just kind of know that Chrome's not going to do that. Typically, it is completely not typical to send a body in a GET request. So like we're just gonna abuse that fact a little bit. Okay, so that's our headers. We have all the stuff that we need. So these are the things that, like, if you're writing a REST API, these are the things that you would need to sort of start to calculate, like what kind of objects you would be returning. So if somebody was requesting, say you had like a to-do list, right? If they're requesting a specific to-do, that would be in your path, and then the method would tell you like if they're getting that to-do, if they're trying to update that to-do with like a put method, things like that. It's a little bit out of scope of what we're talking about. I kind of want to focus on just writing the web server portion. So we're actually just going to continue writing our web server portion, but that's just something to keep in mind. Obviously, path is also useful for a web server, because you have to. That basically is how you're going to determine what web page to return. Here, we're just going to do the simple thing. I'm not going to try to program an application logic into it, because that's kind of, that's your application, right? I don't have an application I'm trying to write. I'm just trying to show you how to write the server portion. So let's basically now, we got to return our response. So let's build our response object, and then we'll just return that. I'm just going to reuse this, and I'm just going to sort of determine that we're just going to be able to we're going to be creating something called a response. We're going to create something in a response variable that we're going to build up, and then we're just going to send all of it. So for this, I actually like to use bytes.io. I don't really have to use bytes.io, actually. I could use a string.io. That's in the IO class. All this is like a memory buffer that kind of looks like a file. This could be just a straight string, but it's a little bit more convenient, and it makes it a little bit more readable if I can do things like this, where I can do write, you can do like line, and then you can write another line and another line and another line, and so on and so forth. It's just a little bit, it makes it a little bit easier to read than trying to build a giant concatenated string. This thing effectively concatenates stuff for you, and you can kind of just, as you call, write. So the first thing we return in a response. The first thing we return in a response is actually the wow. I believe it's. Oh wow! I gotta look this up. I think it's this, and then you give it the error code, or the status code, and then you give it the message for the status code. So there's a bunch of these status codes. Most of the time when you have a GET, it's going to be a 200 OK. For a web server, almost everything you're going to get is a 200 OK. I suppose you could get like a redirect or something, but we don't need a redirect. We're going to send them the document directly. So 200 OK is pretty much sufficient for us. Then we have to terminate with new line. Similar to a request line, a response line. It's just sort of like in reverse a little bit. And then you give it a new line. Once you do that, we're going to we got to do our headers. So we're going to say connection close, because we're going to close the connection. I know they asked for keep alive, but you know what? They can just deal with it. We're going to tell them what the content type is. So content type, this is kind of what, there's a bunch of these by convention. The one we're going to return is just text plain. I'm not actually sure if that's actually the official one. There's probably an official MIME type, but I'm pretty sure Chrome will know what to do with that. We could change this to text HTML if Chrome doesn't like text plain, but we'll see. I was kind of planning to do this with curl, but since my curl is broken, we can't quite do that. Anyway, so that tells us, like, in the body, it tells the client kind of like what is the content. So this could be, obviously here we're sending text, but you could be something like a picture. So you could say this is like a image, like PNG or image GIF. You know, there's a bunch of them. You can say, you know, in application web service programming, this is probably going to be an application XML or an application JSON. Those are two data formats. They're also text-based, but you can kind of hint to the client that it should process it as XML or process it as JSON, because it's kind of useful to know that without trying to guess. Because if you try to run XML through a JSON parser, it will explode. If you try to run JSON through an XML parser, it will also explode. That's not fun to deal with. You should definitely tell your clients, you know, what you've just handed back to them. You don't really need any more headers than that, other than you want to also tell it what the response, the content length is. So this is going to be the length in bytes of your body that you're going to send back, and we're going to just basically do this. So I'm going to take %d because it's going to be a number, so we're going to format it as a decimal, and I don't know the value of that yet, so I'm going to just do length of body, and we will build the body. So that's actually going to go down there. So we have to build. This is kind of an interesting thing here where you can't quite. We need to send the body after the header, but you kind of need to know what the size of the body is before you build the header. So we're going to do that up here. And for that, let's just send our body is just going to be. Let's just do hello world. I'm not very original, if you can't tell already. So, oops, I don't need that. Actually, I'm going to grab that, and I'm going to change this. Okay, cool. So our body is going to be hello world. We're going to set the content length header to the length of that body, and then we're basically going to write. That's the end of our headers now, so we're going to write a blank line. And then we're going to write the body, and that's going to be our hello world. And that's actually our response right there. That's it. Don't have to do anything more. Although I do have to, because this is a byte reader object, I have to do this, where I have to do get, what is it, get value, I think. And then, sorry, it's not a byte reader object, it's actually a string. So actually I'm going to get myself in trouble if I try to write bytes to that. So we do get value to get the full string value. So this has been buffering our string up till now. So we're going to get the full string value out of that. And then we got to turn it to bytes. So we're going to encode it. We're going to encode it as UTF-8. That should be perfectly fine. Actually, yeah, that should be fine. And then we're going to send that. So a little bit of a big line there, but not too bad. So let's give that a shot. Oh, something didn't work. Alright. I mean, unicorn argument. Got string. What? Oh, you know what I just realized? This is Python 2, and I thought I was working Python 3. Easy fix. There we go. Hello world. And that's it. And so we can actually, Chrome has a nice inspect that you can actually pop open. So we actually didn't return all this HTML. This is Chrome doing its styling. But where can you see it? You can go to networking. this. You can go to networking, and then I can repeat the request, and then we can actually capture the network traffic, which is kind of neat. So we're requesting this web page, and so here you can see it just has headers, but I'm pretty sure this is the, it gives you both. So here's the request headers. This is actually the same stuff that it's showing you what Chrome sends. So this should be the same as this. And then it also gives you the response headers. So this is what we set, right? So you can see here we did connection close. Yep, that's us. We did connect content type. Yep, that's what we did. Content length 11. That makes sense because, yeah, it's hello world, right? Same thing. And then we can look at the actual response, and you can see here, this is just the raw bytes of the body, which is just hello world. That's totally what we sent, right? So, makes sense. And that's it. We got a web server. Fancy smancy. Nothing too, and that's it. It's, that's one file of Python, and it's like, what, how many lines? 56. Not even that bad. So obviously this doesn't do a whole lot with the body, but you could. You see here where you have the path variable. So we could actually, have like an if, path, equals index.html. You could set the body to something specific, bring this up here. Else, the hello world. Or I could just, actually, you know what I could just do is I could just say like index, else it's the hello world, right? Oops. And so this is kind of how you would start to build out. So if I do this, it should be hello world. If I do index.html, it should be, that's what I typed, right? Oh, you know what, I forgot this. Oh, come on. Why is my path? It's not equal for some reason. So I have a logic error. Obviously, it's not matching. I wonder if it's because it's bytes. Yeah, it's because it's a byte string. That's what I was hitting with the Python 2 versus Python 3 as well. Yeah. The B means it's a byte object. So I'd have to decode. That's kind of why I have to do that decoding and encoding, by the way. Is that if you want to have it be a string, you got to decode it from bytes. If you want to have it be bytes from a string, you got to encode it to bytes. Yeah. But that's our server. I mean, this basically, you could reuse this and you can start adding your own stuff. But, this is where I kind of need to talk about why frameworks are useful, right? Obviously, there's quite a few shortcomings with this, right? Like I said, the way we're parsing the headers here, this really isn't going to support a body in the requests. If you're going to write a web server or a web application, you're going to need to deal with that. So a framework would do that, although it's not really hard to change this too much into a loop that just keeps going, that it walks through it and then can deal with the body. I've done that before. It doesn't take too much code. But you'd want to change that. This is obviously a single-threaded server or a single process server, so it's not going to be able to handle multiple requests at a time. That's something else that a server or a web framework would provide you that we didn't do. And then also, obviously, the other nice thing about a framework is that it can make the routing based on these variables quite easy to handle. Like something like Flask in Python is able to you're literally able to just say, the path of this path goes, you bind it directly to a function, and whatever that function returns as a string, you don't have to, it'll just basically package it up into a HTML response for you, and you don't have to actually send any of this. You don't have to set headers, you don't have to bother setting the request line. You get a lot of utility about just it dealing with a lot of the boilerplate for you. And then it also usually, a good framework should really help you organize your application code very well and make it easy to read. Obviously they don't all do that. And also it can be dependent on the language, right? Like a C framework, obviously you're limited a little bit by what you can do with C there. something like Python, frameworks are very versatile. They look very differently between the different ones. Like if you compare something like Django versus Flask, those are quite different. Node.js obviously has its own forms of doing callbacks. The Java ones are just basically classes because everything Java is a class, right? But I would strongly recommend using a framework, right? This is more of just an exercise for learning. So it is useful to kind of do the exercise just to learn it yourself. Get that low-level knowledge so you understand how these things work. Realizing that it's just text-based is kind of an interesting concept, right? It makes it it can give you some much-needed confidence, I think, in some cases where you can feel, you understand, well, it's just text. It can't be that hard to sort of just like check the network traffic, in Chrome and see what's coming back, right? Like it shouldn't. You don't need to get overwhelmed by all these framework things that sometimes they throw at you. And ultimately, it's really not that hard. So there we go. You got questions or comments or anything like maybe else that you would want to see? I might try to do some more socket programming stuff. There's many different types of sockets. Obviously, streaming protocols are only one of them. And here we didn't really talk about TCP. We actually more talked about HTTP. So we can actually talk about how you could build like TCP servers if you want to. There's also UDP sockets. There's Unix domain sockets, which are actually pretty useful. I don't see a lot of people using those anymore, but they're actually really great if you for like the one case kind of that they're really good at. Obviously, in the networking world, Unix domain sockets have kind of gone away in use, but they do have a very, very strong. They have very strong advantages of why you would want to use a Unix domain over some of these networking protocols that are more popular today. So if you want to see anything like that, let me know. I can focus on that. I really do like to kind of explore this stuff, and I have a lot of knowledge with it that I kind of would like to share with people because this stuff is kind of a lost art in a lot of a lot of the stuff that I work with on a day-to-day basis. It's all high-level stuff because it affords you a lot of value, but it's also when things go wrong, you do need to have some of this background knowledge to sort of figure out what is going wrong and be able to debug it. And that's kind of where I got all this stuff, right? I spent the hours in debugging it, so hopefully you guys don't have to, and I can spread some of that knowledge on. So anyway, let me know. I'll catch you guys later.